Okay, just for you two guys, what we do is every Friday we have a session. Session is like whatever each employee has learned new that week, they share. So each employee has a turn every Friday. So this Friday it is Karthik's turn. Next Friday it will be somebody else's turn, and they'll share what they learned new about technology, about any other concept. And we are not limited to technology. Anything new, even if they read a new book and they want to share it with it. This is done for two things. This is done not for this is done to help you others also get the knowledge as well as increase your presentation skills. It is compulsory in English that it's meant for you to sharpen your presentation skills so that you can give a presentation in front of people. Okay, Hardik. So what's the topic today?
So my topic for today will be the technologies that I learned during the last 4 months during my internship, which are VR, using basic uh, like plugins of the Unity, and secondly the other applications are of AR, augmented reality, using different technologies of Vuforia, Lightship ARDK, and Immersal. So these are some of the projects that I made. So first one is this bike simulator. It was made in Unity using the Meta Oculus Quest 3S, and the experience is similar to riding a real kind of bike, and the tracking of the control of handle is done real time by using the relative positions of the controllers, which is manipulated by the user. So the model shown here is imported directly from Unity Asset Store, and these dots that are shown here are the waypoints along which these other traffic vehicles would be moving. They are like fixed paths on which the vehicles would move, and also pedestrians are added so that the user can get a realistic feel. Uh, the second one was mixed reality object visualizer. So considering if a person wants to visualize an environment or simply a model of a city or a house in real time, then he can use this uh, MR based, which is mixed reality based application, to place the object in the real world and scale it up and down or rotate it as per his convenience, so that he can experience that he is actually in that place. So that was the second one. We were using the pass-through technology of Quest 3S, which enabled us to
explain them what that scanned mesh means. What is that plus sign on the mesh?
Okay, so before we open the application, since it is using the complete room scale, we need to scan the complete room, based on which a boundary would be created so that the user does not cross it, and like it's basically for the safety purposes. So if the user crosses this boundary shown here, then the complete VR experience would simply disappear and he would be able to see the real world environment. So that was the pass-through technology, and the safe boundary is displayed by the plus signs here. Also, world canvas was added to toggle the scale, or if you want to replace the city and rotate the complete model.
Does the plus sign occurs every time when we are using the જે આપણે જે જોઈએ યુઝ કરીએ ધારો કે મને કોઈ રૂમ વિઝ્યુઅલાઇઝ કર્યો તો તારે પ્લસ સાઇન રહેશે.
Mostly when we get closer to the boundary, this boundary will
If I am still, then plus sign will not appear.
no. And if you get closer to the boundary, then these blue signs will turn to red.
And was this using hand tracking, hand gestures, or just the controllers?
So it was just controllers, but the scaling up and down of the model was like done using the relative positions between the two controllers. Okay. So next I used AR Foundation, which is provided by Google itself for Android devices, and Apple ARKit plugin for iOS devices. So this was simple face tracking, and there was a trivia game that was created. Like the application would detect the tilt of the user, and based on it, it was simply a yes or no type of questionnaire, and an image would be displayed on top of the head of the user, which is basically the question to which he has to answer the questions based on.
No video. So just to explain, it was like there are two questions. You might have seen in the filter. You have to move your head left or right based on that, and then you will be able to get the correct answer. So there are 10 questions, and based on left right, you move your head on the right answer, and that that's how they get the score and all.
So next is the Vuforia image tracking. It is basically a separate SDK provided by Vuforia Technologies, and it, generally speaking, it is better than the generic AR Foundation, which is a built-in technology of Unity. So here, instead of directly adding the images to the Unity as we did in the AR Foundation, creating an image library, we have to upload all the images in a cloud database, and the Vuforia SDK would then detect that how good quality of an image it is which is uploaded, and if it would be easier for the user to detect the image or not. So once we upload the images we want to track in the Vuforia database, then we can import it directly in our Unity project using an API key which is provided by Vuforia, and basically it is a multi-target and instant tracking as compared to AR Foundation, which lags a bit and the tracking is not as good as Vuforia. Now, just as the image tracking, there was also model tracking, for which Vuforia has its dedicated model target generator. So to create a model target, we first have to scan the complete model. Like here we use the Buddha statue, which is here. So we use the iOS device and an external application that would
Which
click.
application we use for that?
It was Polycam, I guess.
So what that means is we have this statue, right? So first we put this statue on this table, and then we scan it from all the sides first. So that way that 3D model, scanned model is generated, and then we upload that to Vuforia model tracker so that we can put AR content on top of the 3D model. Instead of a photo, it's like on the top of a 3D model. So what you see in this photo, that is a AR content on top of the statue directly.
So apart from that, we can also create different views from which the user might aim his camera at the this model. Like currently, the application was set such that the user would get a side view of the model, and the camera or the SDK would detect the model and create this AR experience. Okay, next technology is Lightship. You might have heard of the Pokemon Go game, and the like the experience that they created was made using their own ARDK, which is Augmented Reality Development Kit, named Lightship. So there are various kinds of applications of that, like object detection or plane detection, and similarly there was also this shared AR. So simply speaking, if the host, like when a person starts this application, there are two options. The user can either pose as a host or can be a client. So when a person is a host, then whatever AR content he would spawn or display in his device would be like visible to all the client devices present in the network. So if a project is spawned, it will directly be displayed in like all over the network.
Understand host and client server place. What is host? Okay, and client are whoever connects to that host. So what he is showing is from one phone, if I'm the host and I spawn an object, whoever my clients are, and if they are seeing the same, if they are seeing the same area, then automatically that object will come in their phones. So they don't need to spawn it on their own. So that is the difference. That is a
Different host and
yeah, and shared AR space. That means if I want to play a game in AR, let's say, multiplayer games. So if I want to play a game that that's a car racing game, let's say. So if I'm a host, I create and spawn the track, and all the clients then they can see as a track. And what I can do is, and can the host see the model that the client spawns?
No.
Client cannot spawn the model.
If the client spawns any model, then it will be displayed only in his device. It won't be spawned all over the network.
So it is like just one experience, but each one of them experiences on their own. But what we can do is with this we can have shared AR experiences where if you want to show something but someone is explaining to you, then okay, then one model and the host can just keep on spawning models or explaining it in AR, and rest all the phones can see it at once. So this is, and what's the range? How far does this work? Is there any fixed range of where it
It is
operates?
basically based on the geolocation. We used a geospatial browser based on which a VPS location, which is virtual positioning system, was created.
Is it virtual?
Yeah.
What is VPS?
Virtual positioning system.
No, it is visual positioning system.
Visual.
So what is, you have heard of GPS? What is GPS? Yeah, coordinates, right? What is the full form is geosynchronous spatial system, GPS. So what it does is it creates positions based on coordinates. There are latitude and longitude. In VPS, it is latitude, longitude plus a visual scan of the area. So if I scan this area, if I scan this room and I create a VPS wave spot, then it is called a wave spot. So if I scan this room and create a VPS wave spot, then I can spawn anything inside the room. It will only work inside this room. If I try to spawn it anywhere else, it won't work. So it is using three things: latitude, longitude as coordinates, as well as a visual reference of the room. Yeah, so we have scanned the room first. He did not mention that. We have to scan the room first. Only then the shared experience will work.
Input the data.
Correct. Okay, scroll down here. What's next?
Okay, so next was lightship object detection and semantic segmentation.
Wait. What is segmentation? Guys, what is segmentation?
Hiding a particular thing, like if
Segmentation
if
is
we segment the human,
yeah.
then the background will be removed and we can place any.
Yes. Segmentation means separation. So that means what if I'm seeing something in AR? There are 4 or 5 layers into this. What if I want to separate each layer? Then we can use semantic segmentation. So you'll explain what is semantic segmentation.
So basically, the lightship ARDK has its inbuilt ML model, which would segment all these. There are like pre-classified objects, like we can segment the sky or ground, human, or bottles. Like there are above 100 classes based on which the neural network would segment each of the objects. So semantic segmentation means when the camera aims at a particular object, the data would be fed into its inbuilt neural network model, and then based on the confidence level, it would decide like which object this is, and all the related objects that would be aimed by the camera would be shown by a similar colored material. Like for the application I made, I used simple purple colored material, and if the camera aims at a person, then all the persons like displayed or seen by the camera would be shown in a purple colored material. So that would be semantic segmentation. Similarly,
UV camera.
So, but that is customizable. We can use any color. We can use any segment. What it means is, for example, I want to hide that. I want to hide all the persons from my camera view. I can do that using semantic segmentation, which means I can take this image and just apply an occluder mesh or anything like that. So that way that gets occluded and I can use something else. Or if I want to target something specifically on humans, then I can use that to target my AR object on the human itself.
Similarly, there was this object detection, which would classify the object shown in the or aimed by the camera and tell us which object is being looked at by the camera. It also has predefined classes by the lightship itself, so it would be classified based on any of those. So next is this game that I created using one of the technologies of lightship, which was NanoMesh and its corresponding component named NanoMesh agent. So what this does is it would create a mesh of the surroundings in real time as the person walks, and we can just spawn our NanoMesh agent.
You Mario? Right. So what happens in Mario? There's this character Mario. He in 2D game it is like he walks. He has to jump. He has to collect the coins. He has to avoid the turtles. Right. So in this game, what happens is real-time navigation. Real-time navigation mesh means when I am holding my phone and I'm walking, it will start creating the game in front of me. So whenever whatever distance you walk, the game will keep spawning in front of you, and there will be a Mario character in front of you, and you have to make him walk and complete the levels like that. So this is in Mario in AR.
And there were this for scoring system, the coins would spawn randomly in position in front of the Mario character, and there would be these enemies which would decrease the health of the player if like they attack the player. So you have to just dodge the enemies and collect as many points as you can, and as you walk the mesh would be generated, and this is the simple UI of health bar and point system. So next technology is Immersal, which is also an SDK for Unity. For this too, we have to like scan the complete location we want to create this experience for, and we can create an indoor navigation system. Like if we are in an airport and we want to go from the entrance to a particular gate, then if we have this application built, then the user would be able to like select the navigation target, like currently is from his current location to any of the navigation targets. So in this example, it is the gate where the user wants to go, and it would show this kind of pathway from his location to the entrance gate. So
But what we need to do before we do this, we need to scan
Scan the whole
thing. Only if it is scanned, then it will be able to map out that where you are in correspondence to this. This is very helpful for big malls, big shopping complexes, and airports and stuff, or conferences which are very big. You don't know where to find the way. This can be a helpful tool for doing this.
the only drawback is that the scanning should be proper, and if it is not, then the GLB model would not be created, and you have to manually add the meshes inside the Unity project. That's the only drawback. This was
Any questions? Nobody understood it. One thing, because this game Mario thing, we want to publish it on our Play Store. If it is good enough, why not? We just refine the graphics a bit, make the gameplay proper with all the audios and all, and we can publish it on Play Store. Let's see. Okay, any questions? All done? Yeah, let's.